This is Faruha Frouzan. I'm signal processing algorithm designer at Analog Devices. We are here at CES, and thank you very much for coming to our demo on vital sign monitoring system. Basically, we are having a multi-parameter sensor system and for healthcare. And Roberto, my friend, is going to introduce himself.
Hello, my name is Roberto Muñoz, System Applications Engineer within the Healthcare Business Unit in Analog Devices. We would like to introduce you to our next generation, to a new generation vital sign monitoring platform that allows you to monitor different vital signs 24/7 and later upload all that data to our IoT platform in the cloud. This new generation allows you to measure biopotential measurements such as ECG or EMG based on the AD8233. It allows you to measure to take optical measurements based on the ADPD107 family, optical measurements such as PPG or SpO2. It also allows you to take impedance measurements such as EDA, GSR or bioimpedance analysis. It also features more processing power than our previous generations. This one is based on a Cortex-M4 with floating point, ADUCM 4050, and our ultra-low power accelerometers, ADXL362, that allow you to monitor motion and activity.
So basically what we have is a kind of complete solution from the chip to the hardware to the basically system software, algorithms, and then we provide actually platforms for our partners to contribute to the algorithms and analytics that they want to basically build on top of the primitives that we give to our partners. So here we have a demo to show you based on, so Roberto is wearing a watch, which is a third generational watch. And then we have a demo, we call it the SM Wave tool. And here you can see your different signals, your different biometric signals. Basically here, for example, the first thing I'm going to show you is our optical signal, which call it PPG, photoplastomography signal. And here is the top one is basically the PPG signal, which varies based on your heart rate. And this is like the type of signal that you can see. So LED shines and the photodetector grabs the reflection, and you can see the variation of the heart rate here. On the bottom, basically we have the accelerometer, and if Roberto moves, you can see the variation of the accelerometer in 2 axes. And then we have an algorithm that is running on top of this that gets rid of the motion artifact on the PPG signal, which is very basically sensitive to motion. As you can see, if like he moves a little bit, there are lots of variations in the signal, and we can get rid of the motion artifact and show you the heart rate. And this is the heart rate graph. So the second algorithm that we have is basically HRV, heart rate variability, which provides you with some information on the stress level. As you can see this plot, it shows basically the R-to-R interval or peak-to-peak interval based on the optical signal from the previous basically time versus the current time. And by the time that different PPG signals are coming, you can see different dots in this, and it shows you the R-to-R interval. This graph in the middle basically shows you the histogram of the change of your R-to-R interval. And this basically shows you if your HRV is valid. So the algorithm takes a part of the signal and makes sure that the signal is valid for HRV basically measurement. So right now, Roberto's R-to-R interval is around 700 millisecond, and it's changing from one bit to the other bit. So the third thing actually I'm going to show you is the ECG. So the ECG, basically Roberto is holding 2 of his finger on top and bottom electrode, and then there's one under the watch, and here you can see the ECG signal. So here is the ECG pattern and the heart rate based on the ECG, and you can see we have the basically or the QRPS complex, and we can see that. And the last thing that actually we are measuring with this is body composition analysis that There's basically, it's from BCM view that you can see. And again, we are using the same platform. And here basically we measure the bioimpedance, but in higher frequency, like 50 kilohertz. And you can see the magnitude and phase of the basically impedance of the body. And once you put your parameters, like in terms of age, gender, like weight, height, and your athletic level, your size, and other information, you can get the fat percentage, your fat-free mass based on this measurement. Okay, so just to summarize this, we work on this for basically areas with this watch. One is the acceleration from our MEMS motion sensing. One is the bioimpedance measurement that I showed you. A stress level, basically based on HRV or EDA, we can measure stress level, and then vital sign, optical, in terms of potential ECG, bioimpedance, we can measure multiple metric signals at the same time. Thank you very much for listening to our demo.